This is an AS statistics question on box plots and measures of location and spread. Charlie is studying the time it takes members of his company to travel to the office. He stands by the door to the office from 08:40 to 08:50 one morning and asks workers as they arrive how long their journey was. Part A, state the sampling method Charlie used. Now, when you just pick items or people for your sample as and when they arrive without any particular plan about who you're going to pick or anything like that, this is known as opportunity sampling, because you're just using your opportunity to pick whoever happens to be there at the time. Now, this is sometimes known as, or can also be known as, convenient sampling. So you can use either one of those words. It's convenient, it's just easy, no hard work involved, no calculations involved. Whoever comes to you at the time, you just use that as a sample. Part B, state and briefly describe an alternative method of non-random sampling Charlie could have used to obtain a sample of 40 workers. Now, since opportunity sampling is a type of non-random sample, there's only one other type of non-random sampling that we need to know about, and that is quota sampling. So this can only be the only other option for our answer for part B. Now, to get our sample of 40, because that's what we want, we could, this is just an example, ask one person every 2 minutes, so over 80 minutes, so at 1 hour 20 minutes, he would have got his sample of 40 workers. Taruni decided to ask every member of the company the time, X minutes, it takes them to travel to the office. Part C, state the data selection process Taruni used. The key thing here is he asked every member of the company. So this is not a sample, this is every single person, which is a census. When there is no smaller sample of the whole population, you basically sample the whole population. Taruni's results are summarized by the box plot and summary statistics below. So here's our box plot here, and our summary statistics. N is 95, sum of x is 4,133, sum of x squared 202,294. Part D, write down the interquartile range for these data. Okay, so the interquartile range is the upper quartile, which we call Q3, minus the lower quartile, which we call Q1. Now let's have a look. We can just look at the box plot. Lower quartile Q1 is there, Q3 is here. So Q1, each box is worth 2 because we've got a gap of 10 divided up into 5. So the lower quartile is 26 and the upper quartile is 58, Q3. So we need to do 58 minus 26, and if we do that on our calculator we get 32, or you can do it in your head, it's easy enough, and it's going to be minutes. So there's our interquartile range. Now moving on to part E, we need to calculate the mean and the standard deviation for these data. Now remember, Taruni asked the whole population, he took a census. So this is going to be the mean and the standard deviation of the population. Now that's important because that defines the symbols that we use. So when we want to find the mean for a population, we need to use the mu symbol, not x bar. X bar is reserved for the mean from a sample. So it's the population, and this is going to be the sum of x over n, and the sum of x is 4,133 over n, which is 95. Now that comes up as 43.50526. We'll give an answer to 3 significant figures because we're not asked for any other type of rounding. So that'll be 43.5 minutes, and that's to 3 significant figures. And now we'll look at the standard deviation. Remember, the standard deviation is the square root of the variance. So the standard deviation is going to be the square root of the mean of the squares, so that's sum of x squared over n, minus the mean squared, and we'll use mu for that. Okay, right, so we've got the sum of x squared, that's one of our summary statistics, 202,294 divided by n, which is 95, minus the mean squared. Now we need to use our exact value, not our rounded answer here. So I could just put 4133 over 95. There's our mean, and that needs to be squared. Now, you could also just use the answer button on your calculator if you've just done this calculation. And this comes out as 15.38514. Again, 3 significant figures. So that'll be 15.4 minutes as our standard deviation, and that's 3 significant figures. And part F, state given a reason whether you would recommend using the mean and standard deviation or the median and interquartile range to describe these data. Now for part F, what's going to be having an impact on our calculation is these 2 outliers that are here. They will affect some calculation but not others. Now the outliers, they will affect the mean and the standard deviation because these 2 bits of data are included in these summary statistics, so they're having an impact on the mean and the standard deviation, but they won't affect the median and the interquartile range, because the interquartile range, the whole point of that is that it only includes the middle 50% of the data and excludes outliers, and the same with the median as well, be unaffected by any outliers. So we should use the median and the interquartile range to describe this data. Rana and David both work for the company and have both moved house since Taruni collected her data. Rana's journey to work has changed from 75 minutes to 35 minutes, and David's journey has changed from 60 minutes to 33 minutes. Taruni drew her box plot again and only had to change 2 values. Part G, explain which 2 values Taruni must have changed and whether each of these values has increased or decreased. Okay, so what I'm going to do is actually show these on the box plot here. So I've got a journey that's changed from 75 minutes, so that's going to be in this sort of position, down to 35 minutes, so that's going to be here. So we've got a value that's moved over here, okay, and then we've also got David's journey, which has changed from 60 minutes, this is also decreased in time, to 33 minutes. So we'll mark 60 minutes and then we'll mark 33 minutes, so that's going to be sort of here. So we've got this other value that's moved down in this position, so we've got 2 values that have now moved to below the median. So we can write that since both values have moved to below the median, that's Q2, what this will do is to cause the median Q2 and the upper quartile to both decrease. It's got no effect on the largest value or the smallest value or the lower quartile because they're not below the lower quartile. I'll just write that this will cause Q2, that's the median, and Q3 to both decrease. They're going to get smaller. And if I was to give a reason, I would just say that this is because we've now got more values, haven't we, below the median, or below 40. So this is because we will now have more values below the median. That's our Q2, which is 40.